Okay, so let's begin. Welcome to Friday Happy Math Hour. Today, I'm going to cover systems of linear equations. Okay, these are the topics that I'm going to cover today. Systems of two linear equations and two variables. The first one is going to be determine whether an ordered pair is a solution to the system of equations. We're going to solve systems by graphing, substitution, the elimination method, and how do we use it in real life situations. And then we're going to do larger systems of equations, and we're going to solve them by elimination method, matrix method, and how do we use them in real life as we do application problems with three variables. So to start, this is number one. It says determine whether the given order list of numbers is a solution of the system of equations. So here they give us the point, -1, 3. And they give us two equations. Equation 1 is 2x plus y equals 1, and -3x plus 2y equals 9. Okay, so I'm going to plug in -1 for x and 3 for y because that's my point. Okay, so I'm going to plug it in equation number 1 first. And remember, if it's a solution, it's going to be true for both equations, for equation 1 and equation 2. So after we test equation 1, and if this makes it true, then we continue to equation 2. If it doesn't, if it's not true, if it doesn't make it true, the point -1, 3, then we stop there and we say it's not a solution. Okay. So I'm going to plug in -1 for x and 3 for y. Then 2 times -1 plus 3 gives us 1. So 1 equals 1. So it's true for equation number 1. Okay, then we try equation number 2. So for equation number 2, we repeat the process. We're going to plug in -1 for x, and we're going to plug in 3 for y. Okay, so this is 3. 3 plus 6 will give us 9, so 9 equals 9. So that means that this ordered pair makes both equations true. Then the ordered pair is a solution. So for number 1 here, it is a solution. -1, 3 is a solution for both equations. Now we try the same thing for number 2. But for number 2 now, apply number 2, we have the point 2, -0.5, and we have these two equations here. Equation 1, equation 2. So first, I'm going to plug in the point 2, -0.5 into equation number 1. Okay, so my x is going to be 2, and my y is -0.5. So if I multiply -0.5 times 2, it's going to give us 1, and 8 times -0.5 is going to give us -4. So then, all right, so then 1 minus 4 gives us -3. So -3 equals to -3. So it is this point is a solution for equation number 1. Now we have to try to equation number 2. So I'm going to plug in 2 for x and 0.5 for y. If we notice, 5 times -0.5 is going to give us -2.5. 2 minus 2.5 gives us -0.5. And -0.5 does not equal -5. So the point 2, -5 is not a solution to the systems of linear equations here. Why? Because it has to be true for both. Okay? Does not make both equations true, then the ordered pair is not a solution. So number 1 was a solution, and number 2, it was not. Okay. Now let's continue to the next topic. Is going to be systems of two linear equations in two variables. This is a graphic method. You see, guys, these are two equations, and where they intersect is your answer. So for example, for these two, the answer will be 3, 2. Okay. Now on figure B, on figure B. So for example, going back to A. So this will be one solution, right? X equals to A or Y equals to B. If you have here for figure B, this is a line on top of a line. So this will be infinite solutions. And here, guys, you're going to get something like A equals to A. Example, 3 equals 3 or 0 equals 0. This is what you get when you're solving a system in this form. There's not going to be no x or y. They'll be eliminated. The only thing you're going to have are two constants, and they're both going to be equal on both sides. I'll show you later what I'm talking about. Okay. And for C, these are parallel lines. So they will never intersect. So for C, it's going to be no solution. Example, A equals B, right? Because A does not equal B, right? Because they're different numbers. An example can be 3 equals to 4. So this is no solution because 3 does not equal 4. And again, there's not going to be no x or y. Okay, this is another name for A part. It's called a consistent independent system. B is called consistent dependent, and C is called inconsistent system because there's no solution. Now let's solve by graphing. Okay, I'm going to solve number 3, solve it by graphing. I'm going to graph this very same problem. I'm going to solve it in 3 different ways. I'm going to solve it by graphing, by substitution, and by the elimination method. We are going to get the same answer, okay? But there's different ways to actually get the answer. When your instructor asks you in the test to solve it by graphing, you have to do it by graphing because if you do it another way, it's wrong. Or if they ask you to solve it by substitution, you have to do it by substitution or by elimination method. So whatever the instructions are, you have to follow the instructions or else the problem is wrong, even though you might have the right answer. Okay, so I'm going to show you the 3 ways to solve a system of equations. So here we have equation 1 and equation 2. So to graph it, right, we know that my slope is 3, right? So it's going to be 3 over 1. And my b is -6, which is my y-intercept, 0, -6. This is like a review from chapter 2. Okay, so you guys should be able to graph them. But the difference is that you'll be graphing 2 equations in 1 graph. So going back here to my b, right? This is my my starting point. The b is always a starting point, which is a y-intercept. So we're going to start here at y equals to -6. Then my slope is 3, right? So it's 3. So 3 over 1, which means I'm going to go up 3, 1, 2, 3, and 1 to the right. And then I just connect the points. There's my line. Then I'm going to get equation number 2. So equation number 2, I have to put it in the form y equals to mx plus b, right? That way I can know what my slope is and what the b is, which is my y-intercept. So first I have to try to isolate the y variable. So first I'm going to add 5x to both sides. Once you do that, you're going to have -2y equals to 5x minus 10. Then I'm going to divide both sides by -2. So this should give us y equals to -5 over 2x plus 5. Okay? So then my slope is -5 over 2, and my b is +5, which is the y-intercept will be 0, 5. And this is my starting point, 0, 5. So it's going to be up here. Right? There's my 0, 5. Then the slope, I'm going to go down 5 and 2 to the right. So I'm going to go 1, 2, 3, 4, 5, and 2 to the right. 1, 2. There's my point. Then I connect the points. So the answer is where the lines intersect. So my answer will be 2, 0. That's my solution. Okay. Now I'm gonna solve it by substitution. And all these 3 methods are explained in section 6.1. So really I'm covering 6.1. So solve the system by substitution. We have equation 1, equation 2. Solution. Since y is isolated on equation 1, I'm going to substitute 3x minus 6 for y on equation 2. Okay, so I'm going to go to 2. So I'm going to plug in 3x minus 6 for y. Okay, right? This is my y, 3x minus 6. So I'm going to plug in 3x minus 6 right here for the y value. Then I'm going to distribute. So negative 2 times 3x will give us negative 6x, and negative 2 times negative 6 will give us positive 12. Okay. Now I'm going to combine the like terms. Negative 5x minus 6x, right? Combine like terms will give us negative 11x plus 12 equals negative 10. Now I have to isolate the x, right? So I'm gonna subtract negative 12 from both sides. Right? If I subtract negative 12 to both sides, it's gonna cancel here, and then negative 10 minus 12 will give us negative 22. Then I'm gonna divide both sides by negative 11. So it's gonna give us 2. So now I already have my x value, but remember the answer is a point, an ordered pair. So I need to find my y value. So how can we find the y value? We go back to either 1 or 2, equation 1 or 2, and plug in the value for x and solve for y. In my opinion, guys, going back to equation 1 will be easier because the y value is already isolated. So all we do is plug in 2 for x. And then we simplify. So it'll be y equals to 6 minus 6, so y equals to 0. So x equals 2, y equals 0, so there's my solution. You see, we got the same answer as graphing. Okay. Now I'm going to do it by the elimination method. Okay. To solve it by the elimination method, both equations must be in the form ax plus by equals c. Okay, they both have to be in this form. Okay, that's mandatory for you to be able to solve it this way. So we need to rewrite equation 1 in the correct form, in the proper form. Okay, so I'm gonna subtract 3x to both sides. So it gives us negative 3x plus y equals to negative 6. So I rewrote equation 1 into the proper form so I can present that try to solve it in the elimination method. You see, now they're both in the form ax plus by equals c. Okay, so now here is you have to decide what you want to get rid of, the x's or the y's. In my opinion, I'm gonna eliminate the y's because it's easier. To eliminate the y's, I need to multiply equation 1 by 2. But you know what? I'm gonna do it both ways. On this slide, I'm gonna do it by eliminating the y's. And on the next slide, I'm going to do it by eliminating the x's, just so you see that it's the same thing, but it's up to you how you want to do it. Okay? So I'm going to multiply equation 1 by 2. Why 2? Because 2 times y will give us 2y. Then when I add it to negative 2y, they'll be eliminated. Okay? But you have to follow the math rules. In math, this is permitted as long as you multiply the same number to both sides of the equal sign. Okay? So if we multiply 2 times negative 3x will give us negative 6x. 2 times y will give us positive 2y. 2 times negative 6 will give us negative 12. And equation 2, we just slide it over. Okay? Now we add them. So negative 6x minus 5x gives us negative 11x. And 2y minus 2y will give us 0, right? So these will be eliminated. And negative 12 minus 10 will give us negative 22. Now, all we do is divide by negative 11. So the answer is 2. Now, we go back to either equation 1 or 2 and plug in 2 for x and solve for y. So again, I'm going to use equation 1. So I'm going to plug in 2 for x. And we get y equals 0. You see, guys, same answer. Okay, now on the next slide, I'm going to repeat the process, but instead of solving for y, getting rid of y's, I'm going to get rid of the x's. Okay, I'm doing the same thing as the previous slide. Okay, it's already in that form. Here's where I'm going to, instead of getting rid of the y's, I'm going to get rid of the x's. So here, guys, if we notice, both x's are negative, so I need to multiply 1 by a positive number. So I'm going to multiply equation 1 by 5 or by negative 5 and equation 2 by 3. Right? If you notice, I multiply the first equation by the number on the bottom, and the second equation by the number on top. But one has to be negative and one has to be positive. Why? Because they're both the same sign. In order for you to do this, right, you see this way, the x's will be eliminated. Then we divide by negative 11. So we got the value for y equals 0. Then you repeat the process, right? You can either go to either 1 or 2. For this case, in my opinion, it will be easier to plug in the 0 for y on equation number 2. Okay, so that's what I'm gonna do. So I'm doing everything in contrary to the previous slide, just so you know that you get the same answer. So y is 0. So we get negative 5x equals to negative 10. Divide both sides by negative 5. And the answer is 2. X equals 2. So that's my solution. Are you guys okay up to this point? If you have any questions, please write it in the chat. And Miss Patricia will let me know what the question was. Okay, I'm going to continue. Okay, now, again, remember when I was doing with the graphs, and I said when there was infinite solutions, and when you have something like 0 equals 0, well, this is a case of infinite solutions. Okay, let me show you how this works. Okay, so in this equation, I'm going to call it equation 1 and 2. Okay, I'm going to try to get rid of the x's, so I'm going to multiply equation 1 by negative 2. Once I do that, I'm going to get negative 6x plus 4y equals to negative 8. And I got that by multiplying negative 2 times 3x, negative 2 times negative 2y, and negative 2 times positive 4. And this is my result. So I'm going to slide the second equation over. If you notice, everything cancels. Remember, guys, that I mentioned there's not going to be no x's or y's, just something that's true, like 0 equals to 0. So this means we have infinite solutions. Okay, that means it's going to be a line on top of a line. All right, and that's called a consistent dependent system. Okay, now number 7 is going to be an example of no solution, because we're going to get something like a number, like 0 equals to another number, which is not true. Okay, and this is an example going back, I believe, to the third slide when you had those graphs of two parallel lines. Okay, but let me do the work here. So I'm going to get rid of the x's again. So I'm going to multiply equation 1 by negative 3. If you notice, we get negative 6x minus 15y equals to negative 24 if I distribute or if I multiply every term on equation 1 by negative 3. Equation 2, we just bring it over. And then we get on the left side, everything cancels. On the right side, we get negative 6. You see, guys, since 0 does not equal to negative 6, this is no solution. It means the lines are parallel, and this is called an inconsistent system because there's no solution. Okay? Okay, now, how do we apply systems of equations, solving systems of equations in a real-life situation? This is how you apply it. Okay? This is one of its uses. This is number 8. A 200-seat theater charges $8 for adults and $5 for children. If all seats were filled and the total income, ticket income, was $1,435, how many adults and how many children were in the audience? Okay, so what's my strategy here? Okay, here, guys, we need to find two equations. Equation 1 and equation 2. Like I tell my students, that is going to be like people with people or seats with seats and money with money. Okay, so I'm going to let x equal to the adult tickets and let y to the adult seats and let y equal to the children's seats. If you notice, adult seats plus children's seats must equal to 200 seats because there's 200 total seats available. So by letting x equals to adults and y equals to children, it's going to be x plus y equals to 200. That's my first equation. Now for my second, if we notice, $8 are for adult tickets, right? And the x represents adult tickets, right, for adults. So for the first one, for adult tickets, it's going to be 8x. because the amount of money is $8, and X represents the adult tickets. In a similar manner, children tickets are $5, so that's going to be 5Y. And what's my total revenue? My total income is 1,435. So then it's going to be 8X plus 5Y equals to 1,435. So I already found both equations. Now you can solve it by either way. You can solve it by graphing, by substitution, or by the elimination method. And like I mentioned earlier, these two equations, equations 1 and 2, are already in the form AX plus BY equals C. So it's easier to do it by the elimination method. So here, guys, I'm going to get rid of the X's. I'm going to multiply equation 1 by -8. So it's going to be -8 times X, -8 times Y, and -8 times 200, which gives us -8X minus 8Y equals to -1600. We bring equation number 2 over, slide it over, and then we add them. Right? The X's will be eliminated, and the Y's, -8 plus 5 will give us -3Y, and -1600 plus 1,435 will give us -165. We divide both sides by -3, and it's going to give us Y equals to 55. So I found my Y value, but now I need to find my X value. So since Y equals to 55, I'm going to plug it back into either equations 1 or 2. Again, in my opinion, it's easier to do equation 1 because everything is very small compared to equation 2. So my Y is 55. So I'm going to plug in 55 for Y. So now I subtract 55 from both sides, and it gives us X equals to 145. So what's my answer? X equals to 145 and Y equals to 55. And X represents the adult seats, and Y represents the children's seats. So these are how many adults are in the theater, which is 145, and there's only 55 children accompanied with the adults in the theater. So this is how you work these problems in like a real life situation. This is only one example. Okay. Now these are called linear systems of equations, right? But these are larger. This is going to be like with three variables and 3 equations. For example, they want you to solve these 3 equations. 2x minus 2y plus z equals 3, x minus 3y plus 2z equals to 0, and 3x plus y minus z equals 7. Okay, so guys, at the beginning, we try to rearrange them that we have an x with a coefficient of 1 on equation number 1. Okay, so I'm gonna rearrange if possible. Like I said here, coefficient of 1 on the x being equation 1. So I'm going to switch equations 1 and 2. Right, so I just switch 1 and 2. So this is what I'm going to be solving. Okay. Okay, now, so what's the plan? Okay, here's the plan. I'm going to get equation 1 and equation 2 and equation 1 and 3 and get rid of the x's. Eliminate the x's. Then I'm going to have a new equation 2 and a new equation 3. Then I'm going to get the new equation 2 and the new equation 3 and get rid of the y's. Eliminate the y's. Then I'm going to get something like z equals to c, which means c can be a real number. Okay, so it's going to be z equals to a number, and then whatever that is, right, after all steps, it should look something like this, guys. This is one of the ways it should look. Okay, so, and then I'm going to back substitute to find the answer. So let's execute this plan here, okay, on the next slide. Here we go. Equations 1 and 2. So I'm going to multiply equation 1 by -2. -2 times x and -2 times -3y, -2 times 2z, and -2 times 0 gives us -2x plus 6y minus 4z equals to 0. And equation number 2, we'll just slide it over, and then we add them, and this is what we get. Because negative 2x plus 2x, they're eliminated. 6y minus 2y will give us positive 4y. And negative 4z plus 3 plus z will give us negative 3z. And 0 plus 3 will give us 3. So this is like my new equation 2. Okay? Now I repeat the process with 1 and 3. So to eliminate the 3x, I need to multiply equation 1 by negative 3. So after I multiply negative 3 times every term on equation 1, this is my result. Negative 3x plus 9y minus 6z equals to 0. And then equation 3, we just slide it over. And then we do the operation, we add them. So we notice the x's will be eliminated because negative 3x plus 3x will give me a 0x. And the y's, 9y plus y will give me 10y. Negative 6z minus z will give us negative 7z. And 0 plus 7 will give me 7. And that's my new equation 3. Now I'm going to get the new equation 2, the new equation 3, and get rid of the y's. Okay? So here, guys, a lot of, maybe the way the book might explain it is that you multiply by the least multiple between 4 and 10. But like I tell my students, don't do that yet until you know exactly what you're doing. For now, I'm going to multiply equation 1 by negative 10 and equation 3 by 4. But since they're both positive, that's why I'm going to multiply that one by negative 10 and this one by negative 4. By positive 4. Because negative 10 times 4 will give us negative 40. 4 times 10 will give me positive 40. And then when I add them, they'll be eliminated. But like I said, in math, you can multiply a number to both sides of the equal sign. And that's legal. So if I multiply negative 10 times 4y minus 3z equals 3, right? Times every term, this is what it gives us. In a similar manner, if I multiply 4 times 10y and 4 times negative 7z and 4 times 7, this is my result. So I add them, right? So my y's are eliminated. So here, guys, I divide both sides by 2. So it gives us z equals negative 1. Now, right, I have my equations here, guys. Here, if you want, for equation 1, you can put any one you want from 1, 2, and 3. Or from equation 2, you can put the new equation 2 or the new equation 3, it doesn't matter. But what I do here, guys, I always keep number 1. And then between these two here, between 2 and 3, because I like to keep the new equation 2 because anyway, it's easier, right, to work with because the numbers are smaller. And then for equation 3, well, it has to be what we got here at the end, which was equal to negative 1. Now I'm going to back substitute. What does that mean? Is that I'm going to plug in negative 1 into equation 2 for z and then solve for y. And then once I have my z and my y value, I'm going to go to equation 1 and plug in the value for y and z and solve for x. That's what I need to do. Okay? So z is negative 1, so I'm going to plug in z right there for negative 1 for z. So it gives us 4y plus 3 equals 3. We subtract 3 to both sides. And it gives us 4y equals to 0. We divide by 4. And it gives us y equals 4. Now I have the values for z and for y. So I'm going to go to equation 1 and plug in y equals 0 and z equals negative 1. So I'm going to plug in 0 for y and negative 1 for z. There's my y and there's my z. So after I simplify, it gives me x minus 2 equals 0. We add 2 to both sides, so my answer will be 2. So what's my solution? My solution is 2, 0, negative 1. This is the value for x, the value for y, and the value for z. This is how you work these type of problems. Okay. Okay, now, perhaps this is one of the most difficult topics in 1324. I mean, this is my opinion as experience when I used to tutor students and also as an instructor. But I have a method that I simplified the Gauss-Jordan method in a way that if you follow my plan, you cannot go wrong. Okay, so I'm going to share that with you. Okay, this is called linear systems of equations. Then I'm going to go to Augmented Matrix and then to reduce row echelon form, which is a RREF. This is an example of a linear systems of equations. Augmented Matrix means, you see, I only get the coefficients here. This is a matrix, but only the coefficients. So x is 1, the y is -3, the z is 2, and the constant over here is going to be 0. So in a similar fashion for row 2, I'm going to get 2, -2, 1, and 3. And for row 3 is going to be 3, 1, -1, 7. That means this is an augmented form. Then you have to go to a matrix to reduce row echelon form. This is the way it should look after you're done with it. If you notice, this is the very same one that I just did on the previous slide, but I did it by solving systems of equations in a different way. But now you have to solve them by using the Gauss-Jordan elimination method. So how are we going to do this? You see, I even put like 5 question marks because this is a little bit challenging. Hey guys, like I tell my students in class that while I'm explaining this, you cannot blink, you cannot take a break, you cannot go to a restroom, because if you come back, you're going to be completely lost. Okay, maybe I'm over exaggerating here, but what I'm trying to say here, guys, is that you have to be focused on what I'm trying to say here, guys, in this PowerPoint. And also with my students, I tell them, hey guys, please pay attention. You cannot wander off because you're going to be lost. Okay. Okay. Now, so here's the plan. I call it the 3-step plan. Right? I like to use letters. This is like in real math terminology. So this slide, I'm going to do it like real math terminology. Then on the next slide, I'm going to water it down to students' level. Okay? Because at times when students see too many variables, they get all freaked out for some reason. They don't like all that. Okay? This is augmented matrix. Right? So I have to go from here to something like this. Right? It has to look like this. They're going to be all zeros except for the ones diagonally, right? They're going to be all ones, and then whatever this is, for example, this is my x, my y, and my z. So whatever this is, that's going to be my x value. Whatever that is, that's going to be my y value, and whatever this one is here on the third row, that'll be my z value. Okay, here's my plan. Okay, these are called rows here, right? So these are row 1, row 2, and row 3. So step 1, I have 2 parts, A and B, because I have to make these 2 zeros here, guys. These 2 must be zeros, right? Because if you go on top here, right, in blue, these 2 have to be zeros for step 1, which are the E and the I. So row 2's got to change, and row 3's got to change. After you execute it, it should look something like this, right? This is step 1. Now step 2, right, which is color-coded here in green, is step 2, the B and the Q must be zeros. So row 1's going to change, and row 3's going to change. So after you execute step 2, this is how your matrix should look like. And like I said, all the rest of the letters are just numbers there. Okay, they can be any number, doesn't matter. Now for step 3, the 2 here, right, these 2 must be zeros, which is the value for U and N must be zeros. So these 2 must change for step 3. So I'm going to change row 1 and row 2. And then this is the resulting answer. But hey guys, as you go along, you can simplify, and this guarantees that you're only going to have 3 matrices. I believe the book has about 6 of them or 7 of them. If you follow my method, you're only going to have at most 4, but most of the times you're only going to have 3 if you simplify as you do each step. That's my answer. Okay, and I'll explain all this as I do an example. Okay, now this is the version for students that they don't understand all those letters. Okay, so I'm going to put just number signs. Right, so I'm going to do the same thing as the previous slide, but instead of letters, I'm just going to put number signs. Just so you know, these are all numbers. Okay, so step 1, right, these 2 must be zeros for step 1. You see, so these 2 rows have to change. So after I execute the plan, right, these 2 are zeros. For step 2, this numbers here on top on first row and on the third row, on the second column, those must be zeros. So row 1's gonna change and row 3's gonna change. So after you do the operation, it should look something like this. So finally, for the third step, right, these two here must be zeros, which is first row, third column, and second row, third column. These two must be zeros. So after you execute the operation, it should look something like this. And again, you simplify as you do each step. So this is your result. This means that x equals to whatever the number is there on the first row. Y equals to whatever the number is here on the second row. And z equals to whatever the number is here on the third row. Okay? Now, let's put the plan to action. Okay, so here we have, this is my matrix, my augmented matrix. So this is the answer and reduced row echelon form. You can actually plug this in the calculator, which I show my students how to go real quick and get the answer. But I told them that they have to show me the work. This is only to check your answer, okay? But you can plug this in the calculator, like within a minute, you should get the answer, or less than a minute, but you have to show the work, okay? So step 1, we got row 1, row 2, and row 3. So step 1, right? When you do step 1, row 1 stays the same. And then the 2 on row 2 must be a 0, and the 3 must be a 0. So I'm going to change row 2 and I'm going to change row 3 by using row 1. So I'm going to multiply -2 times row 1 and add it to row 2. Why -2? Because -2 times 1 will give me -2, and then when I add it to 2, they'll be eliminated. Okay? In a similar fashion, I'm going to multiply row 1 by -3. Because 1 times -3 will give us -3, and then when I add it to 3, they will also be eliminated because it will be equal to 0. Now here's my work. First, I'm going to do -2 row 1. So I'm going to multiply -2 times row 1, right? This is my row 1 here. So after I distribute, I should get -2, and -2 times -3 will give me a 6. -2 times 2 will give me -4. And -2 times 0 will give me a 0. Plus my row 2, right? So row 2, I just bring it down here on the bottom of row 1. And then I just add them. Right? So this will be my new row 2. Then I do the second part for step 1, which is -3 row 1 plus row 3. There's my -3, and here is my row, right? My row 1. So after I distribute the -3, it's going to give me -3, 9, -6, and 0. Plus row 3, right? So row 3, I just slide it over. And then when I add it, it's going to give me 0, 10, -7, and 7. That's going to be my new row 3. So this is step 1. If you notice, I accomplished step 1 because step 1, as over here on top, the first column on the second row and third row must be zeros. Now I'm going to go to my next slide. I'm just going to carry this over, and then I'm going to execute step 2. Okay, so this is what I have for step 1. Now here, hey guys, remember the objectives. So for step 2, the first column, the first row, second column must be zeros for row 1 and for row 3. So that means for step 2, I'm going to keep row 2 how it is because I'm going to be using row 2. So the -3 must be a 0 and the 10 must be a 0. So I'm going to change row 1 and I'm going to change row 3. Okay, so I'm going to be using row 4. Okay, now, so I'm going to multiply, since row 1 is already negative, right, for the second column, and 4 is positive, so I'm going to multiply 3 times row 2 plus 4 times row 1. And in similar manner, I'm going to multiply, since these two are positive, I'm going to multiply -10 times row 2 and add it to 4 times row 3. Right? So here's my work. So 3 times row 2 is going to be 3 times everything in row 2, which is 0, 4, -3, 3. After I distribute, it should give me 0, 12, -9, 9. Then plus plus 401, right, which is here on top, plus 401, I'm going to multiply 4 times everything in row 1, which is 1, negative 320, which is right here. So again, after I distribute, it's going to give me 4, negative 12, 8, and 0. So after I add them, it gives me 4, 0, negative 1, 9. And that's going to become my new row 1. Okay. Now I'm going to do the second step. Negative 10 row 2 plus 4 row 3. So negative 10 row 2 is negative 10 times everything in row 2, right? This is row 2 here, which is also here at the bottom. So after I distribute, it's going to give me 0, negative 40, 30, and negative 30. And again, I got those values by distributing or multiplying negative 10 times 0, negative 10 times 4, negative 10 times negative 3, and negative 10 times positive 3. Now I need to multiply plus 4 row 3. So I'm going to multiply 4 times everything in row 3, right? This is my row 3 here. And that's what I have here at the bottom. So after I distribute or multiply 4 times every term here, it's going to give us 0, 40, negative 28, and 28. So I get 0, 0, 2, negative 2. Remember what I said, guys? That simplify is possible. So here we can simplify because we can divide everything by 2. So if we do that, divide everything by 2, right? Every term by 2 is going to give us 0, 0, 1, negative 1. That's my new row 3. Now I'm going to go to step 3 on the next slide, right? I'm going to keep what I have on the matrix from the previous 2 slides. So for step 3, I'm going to keep row 3 how it is, right? Because I'm going to be using step 3. So the negative 1 has to be a 0, right? Which I'm going to change row 1, and the negative 3 must be a 0. I'm going to change row 2 by using row 3. Yes.
There's a question. Someone has their hand up.
Oh, yes, yes. Let me know. What's the question? So I can answer it for you.
Marcel, do you want to turn on your mic? He has his hand raised.
Sorry, how do we simplify?
Oh, okay, okay. Let me go back, okay? I'm going to go back to the previous slide. Let me go previous. Let me go previous. You know what? Let me do this. You know what, Marcel? I believe I'm gonna do it again here, okay? You know what? Let me ensure and go back to the step here. I think I was doing this one here. Let me go back here. I think it was this one here. So I can answer your question because I don't like to continue until the student. Let me see here. Was it this one here? No, was it this one here? No, this one here. I think it was here, my friend. Yes, it was here. So let me go here on the slide here from the beginning here, from the current slide. So I believe it was here, my friend. Okay, so let me quick forward. Yeah, here we go. You see here, Marcel, if every time that you write, for example, here on the previous one, on the 40, negative 19, can I divide a number? Can I divide every term by a number and it'll give me like a positive integer? A regular integer? No, right? Because if I divide everything by 4, it's not going to work because I'm going to have fractions. So for example, here on 0, 0, 2, negative 2, if I divide everything by 2, Maciel, right? I'm going to get 0, 0, 1, and negative 1 because I can divide every term by 2. For example, what's 0 divided by 2? 0. 0 divided by 2? 0. 2 divided by 2 is 1. Negative 2 divided by 2? Negative 1. Maciel, did that make sense?
Yes, thank you.
Can I continue? So you're okay? You're satisfied with an answer?
Yes.
Okay. Okay. Thank you, Marcel. And thank you, Patricia, for letting me know because I don't have my other computer right now. Okay. So now let me go to the next slide, right? So this is where we left off. So again, we're going to do step 3, which means row 3 stays the same. I'm going to change the negative 1 on the first row, third column, to a 0. I'm going to also work to change the -3 on the second row, third column. There has to be a 0. So in other words, I'm going to change row 1 and row 2. If you notice, to make the -1 a 0 on row 3, it's already a 1. So if I add row 3 plus row 1, it's going to give me a 0 on that spot there. Okay, so I'm going to add row 3 plus row 1. To eliminate the -3, I'm going to multiply row 3 by 3 and add it to row 2. Okay, now here's my work. There's my row 3 plus row 1, right? So there's my work. And remember, I can divide here every term by 4. So 4 divided by 4 is going to give me 1. 0 divided by 4 is going to give me 0. 0 divided by 4 is going to give me 0. And 8 divided by 4 is going to give me 2. So that becomes my new row 1. Okay? Now I'm going to do the second part. 3 row 3. I'm going to multiply 3 times every term in row 3. So this is my result. 0, 0, 3, -3. Then I'm going to add it to row 2. So I just bring row 2 over. Then when I add it, it's going to give me 0, 4, 0, 0. And again, this has to be a 1, right? So I'm going to divide everything by 4. So it's going to give me 0, 1, 0, 0, because 0 divided by 4 is 0. 4 divided by 4 is 1. 0 divided by 4 is 0. And 0 divided by 4 is 0. That's my new row 2. And remember, guys, all these diagonally must be 1s. And the rest are 0s. That means that this is my x value. This will be my x. This will be my y, the 0. And the z will be -1. This is my solution. Okay, I'm going to do one more. But here, guys, I have everything set up, right? I have all the metrics because if you follow my method or the method that I got from the Gauss-Jordan method, I just updated it. You're going to only have 3 matrices. Here's my work for every step. So everything is set up. Okay, so step 1. I'm going to make the 2 a 0 on row 2, first column, and also the -1 on row 3, the first column. So these two must be 0s. So on step 1, I'm going to keep row 1 how it is. So row 2 is going to change, and row 3 is going to change. So I'm going to multiply -2 times row 1 and add it to row 2. Then I'm going to add row 1 plus row 3, right? Because 1 plus -1 will give me a 0. Here's my work, right? For the first step, for -2 row 1 plus row 2. So -2 times row 1 is -2, right? Times row 1. Row 1 is 1, 2, -1, 6, right? It's up here. It's going to give us -2, -4, 2, and -12. Then row 2, we'll just let it over, which is 2, -1, 3, 2. After we add them, it gives us 0, -5, 5, -5. If you notice, this will be my new row 2, right? But if you notice, everything can be divided by -5. Because if you keep it like this, the work will be much harder. That's why I mentioned on the plan, right? On the 3-step plan, is to always simplify as possible. And here we can simplify. So we divide everything by -5. This is my result. So this becomes my new row 2. Now let's do the second part of step 1, which is row 1 plus row 3. There's my row 1 plus row 3. Right? We're going to add them. We get 0, 1, 0, 1. So that becomes my new row 3. Now I'm going to do step 2, right? So step 2, and again, guys, everything is color-coded. Even when I do my notes, everything is color-coded. That way students can have a sense of what to do. So here, right, step 2, I'm going to keep row 2 how it is. So the 2 on the first row, second column, must be a 0. So I'm going to change row 2. Change row 1, and I'm going to change row 3. So I'm going to multiply -2 row 2 plus row 1, because -2 times 1 will give me -2. Then when I add it to row 1, they'll cancel. And I'm going to add or multiply -1, row 2 plus row 3. That way it'll give me a 0 also there. They'll cancel. Here's my work. -2 row 2 equals to -2 times everything in row 2. There's my row 2. 0, 1, -1, 2. 0, 1, -1, 2. So after I distribute or multiply -2 times every term, it gives us 0, -2, 2, and -4. Plus row 1, right? Row 1, we just slide it over, which is 1, 2, -1, 6. After we add them, it's going to give us 1, 0, 1, 2. So that's my new row 1. Now let me do the second part for step 2, which is -1 row 2 plus row 3. So -1 times row 2, I'm going to multiply -1 times everything in row 2, which gives me 0, -1, 1, and -2. I'm going to add it to row 3. So row 3, we just slide it over. So I'm going to get 0, 0, 1, -1. That's my new row 3. Okay. Now, I already did steps 1 and 2. Now, step 3, I need to, for step 3, I'm going to keep row 3 how it is. And I'm going to change row 1. And I'm going to change row 2 because these two must be zeros. Okay. So I'm going to use row 1. If we notice, row 3, right, this 1 here is positive, and the one in row 1 is also positive. So I'm going to multiply -1 times row 3 and add it to row 1. And for row 2, right, it's already -1, and this +1, so I'm just going to add these two rows. So row 3 plus row 2. And here's my work. -1 row 3, so I'm going to multiply -1 times everything in row 3, which will be 0, 0, -1, 1. To row 1. Row 1 is 1, 0, 1, 2. So here's my answer for row 1. That's my new row 1. Now I'm going to add row 3 plus row 2. So it's going to give me 0, 1, 0, 1. That's my new row 2. So you see, guys, I accomplished the plan. The ones, all the ones, diagonally there are ones. The rest are zeros. So here's my solution. It's going to be 3, 1, -1. That's the answer for x, right? And the answer for y is, the answer for x is 3, 1, -1. That's my answer. Okay, now I believe I have one more to go. This is the last one here, guys. This is how you apply it in a real life situation, okay? And I'm gonna try to solve this how we did the other word problem, but the other one only had x and y. This will have x, y, and z. Okay, so let's execute a plan here. Now I need to find 3 equations. So I'm gonna do people with people, right? Because this is what it reads. Tickets to a band concert cost $5 for adults, $3 for teenagers, and $2 for preteens. There were 470 people at the concert. The total ticket receipts were $1,950. 3/4 as many teenagers as preteens attended. How many adults, teenagers, and preteens attended the concert? So again, I'm going to do people with people, money with money, and then the last equation, I'm going to get it. I'll let you know later how I'm going to get it, okay? But first, let's do the first 2. So I'm going to let X be adults, right? Just in order, X be adults, Y stands for teenagers, and Z stands for preteens, right? And the total were 570. So it's going to be X number of adults plus Y number of teenagers plus Z number of preteens equals to 570 because 570 were the total people in attendance. So X plus Y plus Z equals to 570. Now for the second equation, I'm going to do money with money. So adult tickets are $5, right? And X represents adult tickets. So this will be 5X. In a similar fashion, teenager tickets are $3, right? And the Y represents teenager tickets. So that's going to be 3Y. And finally, the preteen tickets are $2, and Z represents preteens, so that's going to be 2Z. And what was the total revenue or the total receipts? Was 1950. So it's going to be 5x plus 3y plus 2z equals to 1950. So I already have two of the equations. I need my third one. And most of the times on these type of problems, most of the time the third one is the hardest one to get. So how do we get the third equation? Okay, we use the last sentence here, or the second to last sentence. It says 3/4 as many teenagers as preteens attended. So this is, right, teenagers is Y and preteens are Z. So this is how it looks like. Okay, I know some of you guys might be thinking, well, how in the world did you come up with that? Here's what I tell my students. If it is difficult, write it how it sounds and then flip it. Maybe here, guys, I use the wrong word by flip it. Maybe I should have said switch the coefficient for Y into Z and vice versa. Okay, so now let me show you what it means. Hey guys, doesn't it sound like this? Like 3/4 Y equals to Z, because the teenagers are Y, right? And the preteens are Z. In my opinion, it sounds like 3/4 teenagers, which is Y, equals to Z. You see, that's the way it sounds like, right? Then here's where I put the word flip it. I should have just put switch, right? You switch the 3/4 from Y into Z. This is the correct form. Okay? So now, you don't want no fractions, right? So now I'm going to multiply both sides by 4 because I don't want no fractions. Right, so multiply by 4, we get 4y equals to 3z, because 4 times y is 4y, and 4 times 3z, the 4's cancel, so we got 3z. Now, I have to put it in the form ax plus by plus cz equals to d. So I need to subtract 3z to both sides. So this is my new equation 3. Right? So here are my equations. Right? And then if you want, you can solve it by using the matrix, or you can solve it by using how we did the plan where you get 1 and 2 and 1 and 3, right? Remember that? That I showed you on the first one that I did? Anyway, you try it on your own, and this is your solution. Because I believe I don't have time to actually do it here because time is running out. So that's it for my PowerPoint, guys, and I hope you enjoyed it. And thank you for showing up. Anyway, here's my answer. It should be 220 adults, 150 teenagers, and 200 preteens. Any questions? Okay, let me go back. Let me go back here. Let me stop sharing.
Thank you, Mr. Azasi. Is there any questions for Mr. Azasi at this time? All right, if not, please take a moment to sign in. Your attendance is important to us, and we'd like to make sure you get the extra credit for attending our sessions. And so the link for that is in the chat. I'd also like to that up. There we go. So next week for Tohono Virtual Events at 1 o'clock, we'll be having all about statics, not to be confused with statistics from SSSP, and then over properties of logarithms, exponential and logarithmic equations, and for Math 1324, we'll be going over basic matrix operations and inverses. I'd like to thank you all for joining us today and hope you have a wonderful weekend.
Bye, guys. Bye, Patricia.